Okay, here we are in our series parallel circuit faults. We're looking at a changed value in a parallel for this one. Once again, we are going to do a couple of videos later on that cover changed values and shorts and opens with multiple components in a parallel branch. But for now, this is going to finish up our series. So in this case, we are going to change the value of R2. And so it was 2K, and we are going to increase that to 6K ohms. Now, just like our previous example, the paths for current do not change with change values, just our numbers are going to change. So we're going to start with looking at our parallel resistance values. It was originally 1K ohms, and now, of course, that number will be much different with one branch that has increased to 6K ohms. And we now see 1.5K ohms in our parallel branches. So when we add that for total resistance, we get a new value of 2K ohms plus 1.5K ohms, gives us 3,500 ohms, which is an increase from our original total resistive value. This is again a wonderful opportunity to look at Ohm's law arrow theory, and we know that our applied voltage has not changed. We see that resistance has gone up, and so we expect current to go down. So we look at our total current. It was originally 4 milliamps, and now, of course, we see that total current is 12 divided by our new resistive value that is higher of 3.5K ohms, and we see a new lower current of 3.43 milliamps. So current has indeed gone down. Of course, our next step after that is to start looking at voltage drops. So we look first at the voltage drop for R1. It was originally 8 volts. And now, even though the ohmic value of R1 has stayed the same, we know that current has gone down. So we take that 2,000 ohms, multiply it by 3.43 milli, and we get 6.86 volts. And so R1's voltage has gone down by following current. Now we look at REQ, or the voltage out on our parallel, and we did have 4 volts, and now we have that larger ohmic value of 1.5K ohms multiplied by the smaller current of 3.43 milli, and we get a larger voltage of 5.14 volts. This is something that you're going to see over and over in electronic circuits. When you have components where the ohmic value has not changed, but current has changed, you will find that their voltage drop follows current. So in this case, R1 has not changed, but current decreased, so the voltage drop across R1 decreased. On the other side, you will also notice that when you have components that where their ohmic values change, such as our parallel branches in this circuit, they have increased to 1.5K. So we see there that the voltage drop follows the increase in the ohmic value. And so with an increase in ohmic value, we see an increase in our voltage drop. And this happens over and over in electronic circuits. So keep an eye out for that. Finally, we're going to look at current. In branch 1, we did have 2 milliamps, and now we have our new larger voltage divided by our new larger ohmic value, and we see a much smaller current of 0.86 milliamps. In branch 2, however, we have the same ohmic value, but a much larger voltage, and so we do see a different current of 2.57 milliamps. But because the ohmic value in branch 2 is much smaller than the ohmic value in branch 1, the current in branch 2 is much larger than the current in branch 1. And that again goes back to current and resistance being inversely proportional. So the larger the resistive value in a parallel branch, the smaller the current, the smaller the resistive value in the parallel branch, the larger the current. Okay, and now of course we take a quick look at voltage. And we know that the voltage in branch 1 and branch 2 equals the voltage that is applied to our parallel, which is 5.14 volts, because voltage is constant in parallel. And if we look at that voltage and add it to the voltage of R1, we will of course end up with applied voltage of 12 volts. Alright, and this ends our changed value in a parallel of our series parallel circuit. Keep an eye out in the next few days for those faulted scenarios in multiple components in a parallel branch of a series parallel circuit. Alright, have a great day.